Well, we have used rectangles to approximate the area under the curve, but which geometric shape might provide a better approximation? Obviously not a circle, not a octagon. What are you thinking? Did you guess it? If you said trapezoid, you are correct. Just a very friendly reminder, the area of a trapezoid is going to be 1/2 the height times base 1 plus base 2. And this can be written in any sort of way that you'd like, as long as you have all those variables in there. So let's go ahead and let's find the area. Remember, your height is always going to be the value that creates a perpendicular between your two bases. I'll say that again. The height is the length between the two bases, and you need to have a perpendicular. So our area here is going to be 1/2 of our height. In this case, our height is 2. It's that distance between the two bases that creates a perpendicular. And I'm going to add up my two bases. Well, my bases are the two values touching the height. In this case, a 7 plus a 4. Well, I can always do this first. 1/2 of 2 is 1. So it's going to be 1 times 7 plus 4. Well, that gives me 1 times 11. So our area here is 11 centimeters squared. Shall we do one more practice? I think so. Where's our height? Well, first of all, identify your two bases. The bases are always the parallel sides. So here's my base and my other base. And my height is that value connecting them, that length connecting them that creates a perpendicular. So this would be a height, and this would be a base, and this would be a base. Does not matter which one you call 1 or 2. So our area here is going to be 1/2 the height, in this case 1/2 15. And then base 1 plus base 2 is 20 plus 25. Well, 1/2 of 15 is a 7.5 times a 45, right? I just combined these terms. And 7.5 times 45 is 337.5. And centimeters squared because we're talking about area. All right. Now, interestingly enough, we can actually create trapezoids under a curve. And you might say, hey, Ms. Sorensen, there's only 2 trapezoids here. And you can see you've got a base that's parallel with the base here. And your height would be this because you're connecting your bases. And obviously there's one right here as well. But what if I told you you could actually treat a triangle as a trapezoid if you call your base 1 0, right? Think about a really small trapezoid like that, but you're making this a length of 0, so essentially that just becomes, a triangle. All right, so we can do that. We basically can use the area of a trapezoid to find the area under a curve. So let's do one. Approximate the area under the given curve on the interval 0, 4 using 4 trapezoids and 4 equal subintervals. All right, well, this is really friendly, right? If I'm trying to get 4 trapezoids or 4 subintervals, well, what's 4 minus 0 divided by 4? Say I did 4 minus 0 divided by 4, and I get 1. So the height for all of these trapezoids are going to be 1. So let me just color code this because I like to pretend to be fancy sometimes. Let's go ahead and find the area of this trapezoid. Well, that's going to be 1/2 the height. Well, the height is going to be 1. Okay, so 1/2 of 1. And then adding up my base is going to be 0 plus, what's the height of this? Well, that's going to be f of 1. Well, f of 1 is going to be, meaning plug in 1 into this, the square root of 1 is 1. So we can kind of see it here that that's 1, but we've got a base of 1. Again, just to emphasize this, my base here is 0 because it's a triangle, and my base here is plugging in 1 into the equation, which gives me 1. My height is this value right here, which again is 1 from either this or looking at the picture. All right, so that we're done with this one right here. Let's go different color. Let's find the area of this trapezoid. Okay, well that's going to be plus 1/2. My height again is 1, and now I'm going to add my bases, which is going to be a 1 plus. In this case, we're going to be plugging in 2, right? Because we've got, this is my base right here. That's me plugging in 2, so it's going to be the square root of 2. All right, let's find the next trapezoid. Okay, so this is going to be plus 1/2. Again, my height is 1. And my base is going to be root 2, because I'm repeating this base, plus the square root of 3, because that's the height of that. Just taking 3 and plugging it in right here. All right, and our last trapezoid is going to be this one. So that's going to be plus 1/2 my height, which is again 1. And I'm going to have root 3 plus root 4. In this case, that's going to be square root of 4 is 2, obviously. Now, before we even find the answer of this, I want to generalize this more so that you don't just do it with this problem, you do it with all. Well, this ends up being 1/2 the height of f of 0, which is obviously 0, plus f of 1, okay, plus 1/2 the height of, now it's going to be f of 1 plus f of 2. Notice how in here I have the 1 here and then it repeats, just like f of 1, f of 1. Okay, let's keep going with this. Plus 1/2 the height times f of 2 plus f of 3 plus 1/2 the height of f of 3 plus f of 4. Whoops, ran out of room there. Okay. Now, interestingly enough, notice how you've got 1/2 the height in every single one of these, so you could actually pull out 1/2 the height, and then in parentheses you could have f of 0 plus f of 1 plus f of 1 plus f of 2 plus f of 2 plus f of 3 plus f of 3 plus f of 4. Basically, all of them get repeated, because you can see here how I have one base and then this one, and then I repeat this base and then I have this base, then I repeat that base and I have this, then I repeat that base and then I have this. So the two end bases only get listed once, but these inner bases get listed twice, and you always have 1/2 the height. All right, so that's just me generalizing. But let's go ahead and let's solve for this. So I'm just going to plug this into my calculator, and I get 5.33333. And again, we are talking about units squared because we're talking about area. All right, let's do one more. Hello, keep going. All right. Okay, what about this one? We've got 0, 2, 5, 7, 8, and we can find the trapezoidal approximation method, and we'll have 4 trapezoids. And if you're not sure why, there'll be one in between here, there'll be one in between here, and here, and here. And I really should have said use 4. All right, so this will be, if you can think about this as my first base, my second base, my third, my fourth, and my fifth. So I'm going to have 1/2 the height. Well, the height is actually the distance between the x's right here, okay, from one x to the other x. So in this problem, 0 to 2, that's going to be a height of actually 2. Now my base length is going to be 0 plus 4. Again, those are your y values. Notice here I'm using this y, which is 0, and that y. So I'm going to have 0 plus 4. So that's 1/2 the height, and then base 1 plus the base 2. Now, unfortunately, you might notice this, but we don't have even increments of heights, meaning from 2 to 5, it's actually a height of 3. And then here we're going to have 4 plus 13. Okay. All right, let's go to the next one. Plus 1/2 my height is now from 5 to 7, so that's a height of 2. And then my bases are 13 and 21. Plus 1/2. Okay, what's my height here? Well, my x value changes are from 7 to 8. That would be a height of 1. And then I've got 21 plus 23. Now this has that same sort of format. If you notice here that you've got your 0 and your 23, your ends listed once, and then you've got the 4, 4, 13, 13, 21, 21. And then just make sure you're being careful with your heights, okay? Unfortunately on this one, because your height is not the same, you can't pull it out. You've got to put this whole thing into your calculator. And you get. And I get 85.5, and you should definitely try this on your own. I do not know what's going on here. Okay, I give up. I'm not going to be able to write it down. I get 85.5. All right, and if it helps you, instead of writing 1/2, write 0.5. I think that's a lot easier. Okay, so your answer is 85.5 units squared. All right, thanks for watching.